Welcome, Curious Minds. My name is Rinaldo Aguiar, and this is another episode of Law Enforcement Rapid Fire Tips. And part of this campaign that I'm advancing, Bring Diosdado to Justice, Bring Diosdado to the US. So I'm gonna make this segment one of those Guess Who episodes that I sometimes do. But also, I'm gonna do that, and I'm gonna also, after that, I want to comment on something that I observed yesterday, and I think it could be important. I have the feeling that I'm onto something here, and I wish I was better prepared. Like I had visuals or things that I could, or a script. Like this is not a scripted or prepared at all, right? So it's gonna be a bit bumpy, but bear with me for a second because maybe it's something. So in terms of the Guess Who segment for today, we are going to meet one of the most prominent agents of the PayPal mafia in New York State. And that is Mayor Eric Adams. Very prominent, super flagged in Elon Musk's Geo Index in the pipeline. He said today it's all the models from public records and public data. And besides that, I have some models that process data that it's related to me. For example, emails that I've received or meetings in which I participated or demos that I've given when I was trying to market the technology for key opinion leaders. And there's a lot of nodes, a lot of entities that are connected to me directly during the last 3-4 years because they requested demos or they had meetings with me or they sent me an email or they looked at my LinkedIn profile, things like that. And a lot of those nodes, there's a lot of nodes that meet that criteria that are directly connected to Mayor Adams. So this is, of course, a bit concerning because I figure with such political power in one of the largest cities in the US, where maybe not coincidentally where Travis and those people operate. It's a bit concerning, right? So anyhow, the people that, for example, there's a lady called Denise, I think it's Denise Felipe Adams, I think. Let me see. Let me find her real quick. Yeah, Denise Felipe Adams. And she has a family relationship. I think she's like the sister-in-law of Mayor Adams. There was also a meeting in which there was a former high-ranking police officer that was a police officer since the times that Mayor Adams was a police official or had strong ties to the police force in New York. I don't follow the story much. But anyhow, there was this ex-police officer from New York that also participated in one of these ruses of Nelson Lara. And I think the pipeline believes that he has a loose family connection to Mayor Adams as well. And those were the ruses in which, that was around the time when Nelson set up the meeting with the former First Lady of Panama, Vivian Fernandez de Torrijos. Like it was around the same, like in that space of 2-3 weeks, or like maybe a month, he did all those things, right? Like he set up the meeting with the people and it was an official meeting, like this meeting with the people close to the mayor. The context of that meeting was that these people supposedly wanted to look at the technology to see if they could use it for law enforcement and for terrorist threat detection in New York City. So of course, for me, that was super interesting, right? So that's how they framed it. And like in the meeting, they joined the meeting, they were invited via their official New York City Hall email addresses. It wasn't like a personal meeting. It was an official meeting with officials from City Hall, basically. In that capacity was the meeting. The mayor wasn't there. Initially, Nelson Lara told me that he would be there, but then there was a change of plans, and apparently he delegated that onto Denise Felipe Adams and this other official. And that's how it went. And then around the same time was when Nelson Lara set up the meeting with the former First Lady of Panama. And like people could ask, why was he doing that? I think they had different goals when they set that up, all that. One of them was to give me the impression that Nelson Lara was really connected, right? And he's really connected, but to give me the impression that Nelson Lara was first very connected, and secondly, that he was generally trying to help me market the product. So I would be more open with him and tell him my plans and give him access to an email address of the company, access to the platform, to the Google domain, basically, of the company. And that it was more open, right? And the more open, the more vulnerable. I think that's one of the angles. And I think the other angle, the more subtle angle, it was to give me the impression that I had a shot at marketing the technology. Because as long as I had that impression, that illusion, it was an illusion, right? With this level of harassment and malice, it was impossible that I could sell $1 worth of product. But by giving me the illusion that I could, it was a way of keeping me on the hook working on the technology, which is what they wanted. They wanted me to work on the technology so I could develop it to a point where it was mature and they could steal it without them having to do any work because they don't know how to do it. So that's what they do. Like they surround the target and they create situations in which the target believes has a shot at making this happen. And then they steal it when it's done, when it's complete or close to complete. If they steal it too early, they steal it all the time. Like they don't declare success until they can just take the technology in a point that they can use it themselves. So that's basically the technology that they have, right? Like how to steal technology from other people at a point of maturity of the technology that they're stealing. So that's that. So then Mayor Adams super flag, and I really invite authorities to check out the index and to use XisList.org, the search engine that I built, because they probably have more data than me about properties that he may have, or I don't know, companies that are obscurely owned by him or controlled by him, and I don't have access to that. So more visibility, more data, better results. So that's that. So now I'm gonna switch topics and I'm gonna talk about what I observed yesterday. I'm gonna start by that because it's a pretty interesting thing, right? It unraveled into a lot of insights. I discovered so many things last night that I'm very excited. It was a very productive night. Anyhow, so what happened yesterday? It was this. The pipeline. So I did a small mini project like 2 months ago, which was I created a data set, a small data set that contained the locations from my phone and from my devices, right? I gathered all the locations from my phone, my devices, like all I could for the last 10 years. And I concentrated on locations that I used to visit before, but I have not visited in a long time. Places that I would go to, say, 2016, 2017, and then I didn't go anywhere, any more to those places after that. And then I took that subset of places, and through that analysis, using automated means, I joined it with the rank data that from Elon Musk's database, and I computed the overlap. So basically, I was looking for the join for which places I had visited before in the past, long time ago, and I haven't gone to those places, and are also marked with super high paramilitary scores. The reasoning of the thinking was that in some of the automated systems that I have, I've noticed that there seemed to be like a subtle pattern that they seem to be parking the cars to hide them in places that I rarely visit, because they know that I have the cameras on the car and I have the technology. And then if they go and park, say, the 100 cars in a place that I'm likely to go, they're going to have to decommission those 200 cars, right? The idea was, the thinking that I had was that maybe they were optimizing for that. So they were picking the hiding places for the cars based on what they perceive as places that would be unlikely for me to visit. That was basically my thinking, right? So I did the opposite. I started looking for places with high paramilitary score because I know they're not going to park the cars in a place that is not protected, that they don't have under full control, right? So it has to be a place with a high paramilitary score, an area with a high paramilitary score. I did this small mini project and a candidate came up. It was the apartment complex in 2016 around that time. I went there a few times and then I stopped going to that place. I never visited that apartment complex again. In fact, I think I had dinner with my sister in the restaurant that is in the corner of that apartment complex years ago, right? But I didn't go anymore. So anyhow, this place came up in this experiment that I designed. So I went yesterday to record all the vehicles, suspecting that they probably have a lot of vehicles or important agents stashed in that complex. or hiding in that complex in a way, right? Thinking that I'm never going to go there. So I went and I recorded all the cars. I haven't ran the footage through the pipeline yet, so I don't know, and I don't have any data to give whether they found important agents or not. When I run it, I will know. That said, the important observation was that when I went to that complex, and this is recorded in the videos that I posted all the videos from yesterday. This was yesterday afternoon. I posted all the videos already on YouTube, and they're available and publicly viewable. So it is possible to see in one of those videos that in that complex there was an antenna installed on the ground floor, one of these paramilitary antennas that they have for the mesh network, right? That they camouflage with the DirecTV logo, like they think people are stupid or something. I don't know. They're obviously not DirecTV antennas, right? And I say that because of the size, the number of feed horns, the size of the feed horn devices, the obvious power of those antennas, the weight, the size. It's just too obvious, right? Anyhow, I went there, I looked at the antenna, and I realized that I had seen, so back in the days when I went to that complex, I remember seeing an antenna in a different part of the complex, but pointing to a different direction than this antenna was pointing yesterday. Like the azimuth orientation of the antenna was different, was pointing to the opposite side of the complex. This is what triggered the thought. I thought, and I may look like I'm rambling, but I want to try to reproduce the train of thought so viewers can maybe see how this evolved, and maybe you have other ideas, right? I have to say, before I say any of this, I'm not an expert in this field. In fact, I don't know anything about this field. I had to start yesterday researching using ChatGPT or Gemini, I can't recall, one of those AI tools. I started like asking very basic questions about this topic because this is not my area of expertise. I write software. I know just the basics about satellite communication. So I had to instruct myself using AI to be able to like develop this train of thought last night. But with that said, I'm gonna walk you through what I thought, the way I thought about this problem. Maybe if somebody knows about this topic, they will say, "No, this is wrong," or maybe you have another idea and you can build on what I already thought. Anyhow, so the thought was that I remember seeing a similar antenna, very exactly the same, but pointing on to the other side of the compound. And that got me thinking about this mesh network that they have, right? That is basically mapped on the geo index that I captured. And I know that they route messages and communications from these properties, and these properties are nodes, and I know that the vehicles are nodes, and I know that the iPhones are nodes. Speaking of which, for my segment, sorry for interrupting this, but for my segment of Guess Who for today, I also had slotted Tim Cook, the CEO of Apple. I mentioned this in the website to death. He's super flagged. And the iPhones are a fundamental piece, a fundamental technology piece of this network to function, because all these agents intercept and extract data from the bugs into radio frequency and extract data from the bugs using the iPhones. And I believe that there's a deep integration a hardware integration in the iPhone that makes this possible. Of course, law enforcement should review this, and I'm not by any means an authority in hardware either. But the scale at which they're doing it, and the wide range of bugs that they're able to interrogate with those iPhones, tells me that their iPhones have to be highly customizable, right? To be able to adapt to that wide range of situations that they seem to use them for. And that kind of adaptability can only mean a deep integration, right? If something is not deeply integrated, it cannot be that customizable. It's just a basic logic principle, right? But anyhow, Tim Cook, super flagged, also reported to the IRS. Okay. So the train of thought was that I know that they have this mesh network and they transmit across these nodes. And a long time ago, and this is documented as well in the website, I was doing this, I wrote a program to try to find which satellite they were talking to. Because I see all these antennas, right, pointing to in different directions, not many different directions, just a few different directions. And at some point, naively, I was trying to find which is the satellite that they control. I thought they must have a satellite. I didn't know that this was state-sponsored back then or any of those things. I thought it was a company that had one satellite. That was my hypothesis. So I started looking for this satellite. And of course, my program could never find a satellite that could meet all these conditions of orientations of all these antennas. So it always puzzled me how the thing works, right? And then at some point, I noticed the existence of the trampoline antennas that they put on the ground to do multi-hop tropospheric scatter and to catch the signals coming down. But there was always a question that I could not answer. And I think I found the answer. That's why I'm so excited. But the question I could not answer, I'm going to tell you the question. The question is, if they have all these antennas in all these different geographical points, assume for a second that it's true, they're communicating with each other. So say that you want to send a message from a point A to a point B. If you're going to use tropospheric scatter, you need that angle to be very precise. Tropospheric scatter, basically what it does is that it sends the signal, shoots the signal up to the troposphere, that thin layer that is a border in the atmosphere. And because of the physical properties of the signal and the atmosphere at that altitude, the signal cannot escape the atmosphere, but it bounces back to Earth. And it bounces with an angle that it's guessable, right? Mathematically, one could guess what the angle is going to be. So because of those properties, and this is used in military theaters, by the way, like this tropospheric scatter technology, it's old school method of communication, but it's usually used in military theaters because of its properties, right? Like you can transmit over long distances. It's point to point from one antenna to the other, right? It doesn't require a distributed network, which could prone to interception and man-in-the-middle attacks. So this thing is very secure, and you can go across 300 kilometers, 400 kilometers. It all depends on the angle, right? If you point it, if the angle is very high, then the distance is going to be, because it's going to bounce almost perpendicularly, so the distance is going to be short. But if the angle is small, then the distance is going to be long. And it has other interesting properties. And you can use this to bounce signals over tall obstacles. Because in regular point-to-point communications, you have to have a straight line of sight. But here you could bounce the signal on top of a mountain, for example, or on top of a volcano, like things like that. So you could avoid important obstacles using this technique. So that's why it's used in military and rescue operations mostly. And by the way, this is what back on a year and a half ago led me to the conclusion. Again, this is documented in the website with date when I arrived to this conclusion, that I suspected, this is what led me to suspect that there were military personnel involved in this operation of them. And that's how I discovered that Robert Gates had been Secretary of Defense and also had been director of the CIA and was an employee of Travis Kalanick. I didn't know who Robert Gates was. I don't follow politics, or I'm with all these people on my back all the time. I hardly read the news. So anyhow, going back to tropospheric scatter, the angle is critical, right? And it's with the angle and the azimuth that you can point to where you want to communicate to. What is your end goal? What is your end point, right? What are you aiming to hit? But the puzzling aspect that I could never understand until last night was that I've never seen any of these antennas move. First of all, like they're static, like the Salt Typhoon agents on the house diagonal to me, the 267 and 17 Valley Side Drive, that antenna, when it was there, I haven't checked with the drone if it's still there, but I don't know if they put it back, but when they had it last year, it was always pointing in the same direction, basically towards the south, right? The true south. So the question was, and I've never seen any of these antennas have any motorized mechanisms. I've inspected a lot of them. I have pictures, serial numbers. Through this process, I've really gone to the detail to get physically very close to the antennas to document them. And I've never seen one with a motor on it, like with a motorized mechanism that would allow it to move with remotely or by automated means with precision enough to point to a target. So that was puzzling to me how they do it. Like, how do they control to which house this antenna is going to send the data, or to which property, or to which boat, or to which car? It was puzzling to me. And I think I found the answer. I'm 95% sure that this is how they do it. And again, take it with skepticism, because I'm not trained in this area. I've never received any training of any kind, formal or any kind in this, so I might be wrong. But this is what occurred to me. If you want to change the angle, right, it's this tropospheric scatter technique, there's two ways to do it. One, you can move the antenna. right? You can move the angle of the antenna or put the antenna further away or move it in any of the axes that you could move it. And that would effectively affect the angle. The other way that you can move it is moving the target, right? The same principle. You can move the target, that will move the angle, but the target is fixed most of the times if it's a house, unless it's a boat. But for the sake of the argument, let's assume we're talking about two fixed points, okay? So you cannot move the antenna. The only other way you could move the angle would be by moving the reflection point in the atmosphere. And that's when I thought, I mean, it sounds like impossible, right? How can you move the reflection point in the atmosphere? And then I remembered that I picked up using technology means last year. I think it was last year. Yeah, last year, late last year. That many of the solar panels that these houses in the mini compounds, by the way, I believe these Chinese people in front of me, I think it's really a mini compound. It seems like it. At this point, I think the two houses are really the same compound, the same thing, right? Like it's not really two families. I think it's a mini compound. And that's why they have that secret gate in between the two properties. The same thing that we saw at Lake Point Estates with Eckhart and Muller, who is another former CIA director. They have a gate that allows a person to pass from one house to the other on the backyard of the houses without being seen outside of the house. And it's because of that, because all those houses are in reality a single unit. So anyhow, where was I? Yeah, I'm moving the reflection point. So it occurred to me, I remembered this was a train of thought. And I'm sorry that I'm trying to remember what I thought. It's just that I want to walk you through how I arrived to this conclusion because it might help. I remember that the house in front of me, which is 26711 Valleyside Drive, and I believe it's part of this mini compound with the other Salt Typhoon house, has a series of solar panels in the roof. Okay. And these solar panels are to power the antenna that the other house had tucked behind the fence. But I programmatically picked up last year that those solar panels are aligned exactly, but precisely with the optimal orientation of Starlink and of the Starlink. So at some point I was using a Starlink when I didn't know that it was really a Chinese company using Elon Musk as a frontman. But before I knew that, I started using a Starlink and I thought I could avoid them intercepting the traffic. So I was moving that antenna all the time and trying to make it hard for them to drop on the downlink. So in that process, I became very familiar with what is the optimal orientation of the Starlink antennas here in Katy, Texas, because this, of course, varies by the exact location where you are, right? In different locations, the orientation, the relative orientation that would be optimal for Starlink will vary. But here, while I was here, I know what the orientation is, and I know that the house has the solar panels aligned exactly, but with a tremendous precision, with the exact orientation that would be optimal for Starlink. And based on that, I created a system, a small pipeline that basically looks for that, for the orientation of the solar panels in houses marked with high paramilitary score in the index and typically end in 07, like the house in front of me, because that's the engineering channel, so Typhoon engineering. And then compare that with the orientation, detect and set level imagery of those solar panels of that candidate house with what would be the optimal orientation for a Starlink connection in that specific location. And then and then group together the houses that match that criteria very closely. Surprise, surprise, it seems to be a thing. Many of these houses across the country, in different cities, states, have these properties, all of them. Are marked in the index with high paramilitary score or crypto payments. The street addresses end in 07 and have solar panels on the roof, installed on the roof that align exactly with the optimal orientation of a Starlink in that location. So based on that, last year I hypothesized that maybe some of those solar panels are really antennas, Starlink antennas that are covered. So it's not obvious that it's an antenna, and they probably do that. So there's no temptation on law enforcement and such to try to eavesdrop on them because they would think they're just regular solar panels if they're being investigated. So those are probably solar panels acting as antennas, is what I'm saying, and are probably used to transmit information that could be sensitive. That's why they have to make them look like solar panels. Okay, so I remembered that, okay? And that thought of the orientation of the solar panels made me think about what if, and this is the crazy idea. And I'm careful when I use the word crazy because like Morgan Heibner and Diosdado Cabana campaign to say in a court that I'm crazy and that I need to take medication. So I try not to use the word crazy, but it is a crazy idea. Okay, it is a radical idea. What if this is the idea? What if what they're doing is instead of moving, the antennas are always fixed, pointing towards one of these four cardinal positions: north, south, west. And what they're doing is bouncing the signal, so shooting the signal at the exact moment where such that when a Starlink satellite passes at the exact point such that the signal hits the body of the satellite and produces the angle that they need to hit the target that they want. So imagine that. You have the antenna fixed, right? And you have a constellation. I'm going to talk, and again, I didn't know any of this about, well, I knew some of it, but not to the detail that I know now because I had to investigate this last night, right? So I'm going to tell you what I've learned in case it's wrong. I don't mislead you. So I give you the opportunity to correct the information, right? So imagine that, right? So the way these Starlink satellites, from what I understand, work is really a swarm of satellites. It's a constellation, they call it. And in reality, it's not a constellation. It's a constellation of constellations. So they're small groups or clusters of satellites around the Earth. And this is why I said that I don't have the visuals. Imagine that you have the Earth, okay, rotating. It's a globe and it's rotating. So these satellites, from what I understand, are traveling in two directions, from south to north at an angle tilted between 53 and 85 degrees of inclination. So they're not traveling from south to north, like true south to true north, but they're traveling inclined relative to the Earth. And there are other also satellites, Starlink as well, that are traveling using the same pattern, but on opposite direction, north to south, with a similar inclination relative to the globe. So basically you have these clusters, and there on each direction there are many constellations, right? So you have these mini clusters of several satellites traveling with certain inclination around the Earth, like that, and on the other direction, okay? And these satellites also are traveling at different altitudes, okay, and with different speeds. So it's a very complex mathematical problem, and it touches on things like physics, kinetics, geometry. It's a very complex problem. It's not easy. The mathematics of this are not easy, okay? But it is possible to pick the right satellites. Imagine you have the antenna pointing at a fixed angle, right? And you have these constellations of satellites circling in this way. It is possible to pick the right satellite, basically picking two of the. So these are three side America. Imagine X, Y, Z. So you basically can pick a satellite with those three coordinates such that given that you have the other 2 points in this triangle fixed by moving the point that is variable, which would be a satellite that you don't know yet which one it is, right? But the satellite could meet these criteria that passes at that point at the specific exact time where you're going to shoot this radio frequency directional signal up. So the signal bounces off the satellite because the satellite is made of metal or some reflected material, reflected to radio frequency. And then the signal is going to come down with the right angle and it's going to hit the target, right? So that's the radical idea. Now, I get excited just to think about this possibility. First of all, it's super ingenious if this is what they're doing. And then, looking into this and learned a little bit about the different things. And like, I'm going to try to export the chat with the AI conversational thing to kind of, I don't know, I think to review it later. And if it doesn't export, like it's too large and then it crashes the browser. But if I manage to export it, I will put it on the notes because I think it could be useful, right? Like, people to review these concepts. Of course, the fastest path is to find someone who's an expert on this, right? And consult with them. But I don't know, it seems to me like a super fascinating field. Anyhow, there are also other types of satellites. So Starlink are what they call low orbit satellites. So that means that they fly above sea level at around 550 kilometers. So it's relatively low. And this has a lot of desirable properties. They're cheaper to launch. That's why they can launch thousands. There's in these constellations that I was describing, Starlink alone has today, I think, 7,500 satellites. So there are a lot of them. So the mathematical problem is what you need to do, what it comes down to, right, is you need to compute or calculate which could be a viable satellite in the future, say 5 seconds from now, because you haven't sent, you need to calculate which is going to be the satellite. First, you need to calculate what could be a viable point, okay? A point that would meet this geometry that you need to hit that target. Then, knowing the point, you need, knowing the positions of the satellites right now, and some of their physical properties like velocity, coefficients of travel, angles, like there's a lot of things, and this is public data. So knowing those two things, the point that it's a viable point, and there might be multiple viable points, right, to hit these targets, are in the altitude and the other two coordinates. But knowing the candidate points or a set of candidate points, the question is, which are the satellites, given the data, the snapshot that you have about the satellites right now, that in, say, 5 minutes could pass or will pass on those specific points, candidate points that you computed. And it's a very interesting problem because it's not only about a space collision, but also about time collision. Because then you have to fire the signal at the exact time to hit the satellite at that point when it passes exactly that point. And remember, this math here is complicated because the time that it takes for the signal to travel from the antenna from Earth to that specific point varies, right? Because it is not an instantaneous transmission. It could be 3 milliseconds, I don't know, 2 milliseconds. I don't know how many milliseconds. I know when I ping something on my computer, on a Starlink, sometimes it comes back around that, 80 milliseconds or 100 milliseconds. But of course, that is a multi-hop thing, right? So it's probably less than that. It's probably 5 milliseconds or 3. It must be in that order, I believe. But I will look it up. And you have to factor this in, right? So what I'm saying is that you have to also factor, and sorry, I'm going to give you spoilers alert. The reason why I know about the intricacies of this problem is because I solved it last night. I worked on this last night, and I have a prototype that does this. I'm going to show you how it works, and I'm going to open source it so anybody can look at it. And my reasoning for doing that was, well, to understand, right? This lets me, and this is why I'm so excited. This allowed me to understand how does their network work, because now I can see the technical limitations of their network and the things that they have to do to operate the network. And this is what I've done all these years to counter their attacks, right? But this one was super interesting because it was one of those that I was never able to crack in years. So anyhow, so that's the mathematical and physics and kinetics problem, right, that are combined into this. But that is basically a technique, I believe. It's a theory to be proven by authorities. I think the only people that can really say yes or no are authorities, or I wouldn't say even industry experts, because they control many industries. They can get an industry expert to say anything, right? I think the only people that we could trust would be telling the truth would be federal authorities. And it's an interesting thing. And I think this is, I'm not even qualified to even think about these things, right? Much less to talk about them. But it makes me wonder, right? Imagine for a second that this is the case, right? That they're using the Starlink satellites as bounce points to colonize other countries, right? Because that's what they're doing, committing crimes and colonizing countries, right? What are the legal implications for that in terms of, so I don't know, crazy question, right? Can the US say that this is true and it's proven, and they determine that, yes, they're doing this, right, with these satellites? Can the US shoot down all the Starlink satellites? Legally speaking, I don't know if there is a legal framework in the world that regulates these things, right? I imagine so, because otherwise, countries like Iran and China would start flying military satellites on top of the US, right? Or when the Chinese sent the spy balloons that were controlled with this network, I can tell you that, they were shot down. So I imagine, but I don't know, like I guess the question is the altitude, right? If at that altitude, legally speaking, if this government has powers, jurisdiction to shoot them down. And if that's the case, right, what would that mean for global communications if all these satellites come down one day? I don't know. It's a chilling question, really. It's chilling, really is. Okay, so that's the thing. And then I understood a lot of other things, right? Like, for example, I can tell you, I understood that because of this angle in which the satellites are moving, right? It is easier, first of all, and these are low orbit satellites, the Starlink satellites, right? I understood one thing to give an idea that if you want to send a transmission in this way over a long distance, 5,000 kilometers, say that you want to send, I was trying with my prototype to send a message from Bogota to New York, okay? And I could never find one Starlink satellite that would meet the geometrical and kinetic conditions at the same time. And I was puzzled by this, right? But then I understood it's because the satellites are flying so low at only 550 kilometers, and that distance at the base of that triangle is so large, 4,000, 5,000 kilometers, that it's just impossible to meet those conditions. Or think about it this way: the horizon at the equator, because the Earth is inflated in this direction, right? So imagine that you position a triangle in that way between New York and Bogota, right? With the dimensions that I'm more or less describing, you can see that the base of the triangle would have to be underground or under the sea. It's the only way. It would have to traverse the Earth, so it's impossible, right? It doesn't work. The only solution to that problem is to use a satellite with a higher altitude. It's the only solution, right? So the geometry can be met. And this was a revelation for me, because this means that they're not only using Starlink, they're using other satellites as well. And by the way, when I say this, bouncing the signal, what I mean really, to be perfectly clear, is bouncing the signal of the body of the satellite, of the object, without active collaboration with the satellite. Meaning, it's not like the satellite is listening and then retransmitting. No, that's not what I meant. The satellite is just passing, minding its own business and doing what it's supposed to do, whatever purpose it had. And they send the signal and shoot the signal in a way that hits the satellite and bounces off back to Earth to a point where they want, without the satellite maybe even knowing that it happened. And here I injected a word specifically, and I thought about this before giving this demo. I injected the word actively. I said, without the satellite actively collaborating with them. And this was on purpose that I said this. And this is something that I thought that is also chilling. It's a chilling thought. And bear with me for a second. Imagine that you're the Chinese, right? And you come up with this technique that you're going to bounce signals off the satellite, and you start building this SpaceX company in the US, fronted by Elon Musk, like, as Elon Musk is a visionary, building this thing, right? But it's really you, the Chinese, doing this. And you have this plan in mind, right? That you want to deploy these thousands of satellites so you can basically have this global network running all the time, working without nobody knowing that it's happened, right? If I was Xi Jinping, I'm not Xi Jinping, and I would never do the things that he does. But if I was Xi Jinping, I would polish those satellites. I would make sure they're shiny, that the body of the satellite is a perfect reflective structure. Because this is another thing. In the math, that I want to show you the math and I want to show you the code, there are certain assumptions. The assumptions, for example, one assumption is that the reflection is perfect, that the satellite, in my math, right, that the satellite is a mirror, okay? Not perfect, optimal, let's put it that way. Because, yeah, perfection in these scenarios, right, is something that is very hard to chase, almost impossible to achieve, but imagine that it's optimal, okay? If I was Xi Jinping, I would make sure that all my Starlink satellites would be polished in a way that maximizes the chances of success of this technique. And these on itself, if those satellites, if somebody has access to those satellites and to the exterior and the design and the CAD designs, etc., and the material, this could be evidence, right? That they were deliberately made for this purpose. And there's another chilling thought. Remember when we talked about the collusion in the market between, alleged, right? Between Amazon taking the head queries of shopping and eBay taking the tail queries of shopping? This measurement that I took 2 years ago, Bezos from Amazon also has another competing company launching satellites into low orbit. And if the two companies are producing these satellites with these polished exteriors designed basically to make this possible, it also shows collaboration in that sense, right? Between these two seemingly disparate actors. I'm talking about Starlink, SpaceX, and Jeff Bezos' space company, right? So it could be something, right? But it would require inspecting those satellites to see if the exterior of the satellites were optimized for this. So it's an interesting question. From a purely investigative angle, right? And if I can bring it back to the whole conversation about where we are right now, this is exactly the flaw in everything that they do, that they standardize things so much because they are thinking at planet scale, because planet domination. They standardize them so much that it's easy to see that there's coordination, right? Like with the head queries and the tail queries. The problem they were solving with that, the reason why they did that split, in case it's not obvious, is because they couldn't, first of all, it's billion of queries, right? And then they would have this problem, oh, you're taking my query, give me back the query. Like they can't be on that back and forth because it would make the market collusion us. And they can't be recording on a database who owns which query, right? So what they did was we're gonna split the distribution at the, I don't know, 7th percentile, right? They picked a number and they probably negotiated even what that percentile would be. Because, and this is something I didn't mention yesterday when I said that or the other day, I talked about the area under the curve. I said that's what matters really. It's not the frequency, it's not the number of queries, it's the area under the curve. That is actually not really accurate. If you want to know what really matters, the formula of what matters here for that split, right? Because if you know the formula and you can see that they split it equally or almost equally, I think that's another data point for collusion, right? So what really matters is, I'm going to describe how you can calculate that number. What you have to do is convert each query in the distribution to the NavBoost canonical query, okay? And then get from Google Ads the average cost per click of that canonical NavBoost query for all the queries in this distribution, even the tail queries. Because if the query is, I don't know, toy robot 1975 part, right? The canonical query that is probably Star Wars robot, right? And that query matches to a head query. So it's a way for you to normalize the distribution on the query dimension, right? To normalize everything to head queries. And then you multiply the frequency of the non-normalized query by the CPC, the cost per click value of the normalized NavBoost query. And in that way, you can compare apples to apples. Right? You can see what is the monetary value of the tail that eBay is taking and the monetary value of the head that Amazon is taking. Yeah, it's mind-blowing. Okay, but back to the problem of the antennas, right? What I was saying is that there's the low orbit satellites, and there's also other types of satellites. They're geostationary, I'm sorry, my pronunciation, these words I don't, English is not my first language, and I have a working, as you can see, working use of the language, right? But there's certain words that I don't know exactly how to pronounce them. So there's satellites that are geostationary, there are satellites that are low orbit, and they're different kinds, right? And there are ones that fly very high above the Earth. And of course, there's also the question of cost. The higher you deploy the satellite, it's more expensive because you need more fuel, a bigger rocket. The satellite is heavier because it has to resist greater challenges, let's put it that way. And all it makes the thing exponentially more expensive. But one of the things that I discovered is that for long distances, there's no way to do it unless you use the higher orbit satellites, the ones that fly above the Earth at a greater altitude. Okay. But so this is an amazing discovery yesterday, because then I was basically able to codify this thing. And I have a system, and I'm going to show it to you. I'm going to give you a quick demo that you can basically simulate this situation that I'm describing, and it will find for you which is the satellite that will pass at this particular point in 5 seconds from now. And if you fired your signal exactly at that moment, you would hit the target, right? Like it does the calculation for you. And I also understood multiple things about how their network operates in this level, at the transport level, the physical layer, right? For example, I can tell you, because I know that antennas are not moving, right? So I understood that the mechanism, like the computation that you do, if the antenna is fixed, versus if you can move the antenna is very different and has different constraints in terms of what is the probability that you can find a satellite that will meet this criteria. It's very different. It's a very different computation in many aspects. Okay, the kinetics are different. The number of candidates, the way that you could eliminate the candidates to make the computation faster. It's a fascinating problem. But it also tells me, it also allowed me to see why is that they need the boats. That's why they need the boats. So those boats that they have at Lake Point Estates, and the question I asked 3 days ago, why they had those points in the lake, in this small artificial lake in Spring Lake, Katy, Texas, is because of because these points, if you have a mobile antenna, like mounted on a boat, and you can move it. You can move it by just moving the boat. If you move the boat, the antenna rotates with the boat. If the antenna is fixed to the boat, you move the boat and the antenna moves as well. And you can also move the inclination easily because you're on a vessel in this case, right? And the other fascinating thought was plane, right? How planes, you could use the same technique with plane. Instead of hitting satellites, you can hit planes. Imagine what they can do with that. So they could use the commercial routes of planes, which are known and predictable. This is better than satellites because satellites have a problem. The kinetics are, and I didn't know this, I learned this last night. The kinetics involved, because the orbit of the Earth is imperfect, it tilts all the time, and the rotation is imperfect. All these things, like the duration of the day, is imperfect in reality. So all these things factor into that. It's a very hard computational problem, and you have to compute all the possible positions in the future, given as an input only the snapshot right now. Like you cannot predict the position of a satellite 5 days from now. It's just you can't. You have to have a closer snapshot so you can do the computation over a period of the next hour or so, right? That complicated is the math. But with a plane, it's first it's predictable, it's known, the trajectory is known, it's predictable, and also they can control it because they can control the pilot, right? Or they can control the traffic controller. And it's an object, a huge object made of metal, right? Flying above. Interesting. It's just too easy, right? If they're doing all this with these antennas, with these satellites, which is a way more complex and difficult problem, right? With less both probability of success and capacity of bandwidth, right? Because this satellite will be in that position for a very short period of time. And this brings me to another interesting property I understood. Their network, the one that they use with the satellites by hitting them, it's an asynchronous system, really. Because say that I'm a spy, okay? Imagine that I'm a spy, and I'm spying on the people next to me. And I want to transmit something I stole, information I stole, or audio that I recovered from them. I don't know right now, the agent will never know, but the system doesn't know when will a viable satellite pass at the exact point to be able to hit it to send the data to where it needs to be sent, right? So it's a problem that it's open-ended. That satellite could be an hour from now, could be 2 hours from now. So it is possible if they have to send the data to that specific, there's 2 ways to do it, right? One is you wait. So you wait for the right moment, okay? But this could mean that you will have to be holding that data for an hour, for 2 hours, right? Until the right satellite passes and you can really ship it. The other way is, and this is probably how they do it because they have so many houses. I guess the answer depends on how many houses you have, right? If you're in Katy, where they have about 90% of the houses, they can just send it with one of these spy cars that take data from one house to the other. That's the function of the cars, one of the functions, right? The agent comes with a device with an iPhone, takes the data, drives to another house, and the iPhone sends the data to that house. So if this location would take an hour to transmit this data, in Katy at least, because they have so many properties, they could just ship the data locally with lower latency, say 5 minutes, to take it to a different house 2 kilometers from here, where the antenna has a different orientation or different angle, whatever. And maybe that house has a shorter lead time for for a viable window of transmission. So that's what I would do. I would basically index the capabilities of the houses, right? And then with this index, pick the house very quickly that is more likely to have a satellite. I would optimize for that. Because I think in this world where they move, it's dangerous to hold the data. If there's a raid and the FBI comes and captures the house, they capture the data, right? So they can't be holding the data for a long period of time. So I think that's probably what they do. I think they probably reroute, right, the traffic. I would, at least I would do that. What else? I also understood things like in this, so there, as I was saying, there's two ways of transmission, right? One way is two arbitrary points, right? The latitude and the longitude doesn't need to match, okay? In this case, for this case, you need the antenna to be movable. You need to move the antenna. Why? Because if one house has the antenna pointing to the north, right, and the other house is here, you will never hit it. If you hit a satellite on the true north, imagine it's 2D, right? The signal is gonna come down in this direction, and you're never gonna hit this house, right? It's gonna go like this. So in this scenario, you need to be able to point this way, so you hit it, and then you hit it, right? So that's why they need the boat, and that's why they need to mark the points in these nautical points everywhere, right? In lakes and near the Pentagon, there's a marina that they have full of points. Of course, because they need to be able to steal data from the Pentagon and route it this way flexibly. They cannot use fixed antennas in that scenario. But in Katy, where they own all the houses, and the houses are fixed to the ground, they don't have that problem, right? So they use the other technique, which is the antenna is fixed, and I'm just going to wait for the right satellite to pass. But then in that case, you basically have to make this trade-off. We have to be flexible, right? In the sense that just to play with your constraints or the constraints of your problem. So if you cannot move the antenna, then what you have to do, you make the constraint that, well, houses will talk to other houses that either fall on the same longitude, so south to north or north to south, and or on the same latitude, meaning east to west, west to east. And then you can do it without moving antenna. I also understood that because of these properties of how the satellites moved, the probability that you will find a viable satellite that will fit this geometrical and kinetics problem is higher if you are transmitting from east to west than in any other case. That is the situation that maximizes the probability of finding a satellite. Because of the direction of the rotation of the Earth, the satellites, the majority of them, appear relative to the position, right, of the sender and the receiver, to be changing position in a slower fashion. So the time window that you have to hit it is higher. And this is another problem, that the computation is not continuous, okay? Because of the complexity involved, you cannot compute, okay, what all the number, right? We're talking about 7,500, so 7,000 satellites just as Starlink, and there are others, right, that you can use, just from the public data. And you cannot compute, what I was going to say, you cannot compute, what are going to be all the positions of all these 8,000 satellites every second for the next hour, right? You will have to do this 3,600 times for 7,000, 8,000 satellites, right? So it gets into the millions of iterations, 24 million iterations. It would take you hours to compute that, and by that time, the satellite is gone. It already passed, right? So what I'm doing to solve this problem is sampling, right? I compute candidate points every 30 seconds, for example. But that makes it so that it is possible that the right satellite existed, but it passed at a moment that you did not compute, like you skipped over it in time, in the time scale, so to speak. And I'm sorry, this is probably getting too technical, right? Yeah, it's a challenge for me not to go deep in technical things, but it's super, super interesting, right? And the other thing I understood, and I don't know if viewers would recall this, but if you see this, right? Let me see if I can show you this. A demo that I've recorded. By the way, I recommend you watching this video. But what I want to show you is this image, right? So you see the screen that I'm showing is partitioned in two. You see this that looks like a heat map. If you look at it, right? So that's the Earth, and that's a heat map of where the paramilitary points and the antenna location points are marked in the index. And what's interesting, if you look at it, so that's you can see the world behind, but like that big underneath, but that big band of red in the middle of the image, I'm talking about here, this is basically the equator, okay? That's the reason why that heat map looks like that. Is the dynamics of the satellites. Is because that's the band where they have the highest probability of hitting one of these satellites when transmitting from east to west. So what I'm saying is that the backbone of this network is very interesting. It's built in a way that optimizes for probability of being able to transmit, because it's not guaranteed, right? It depends on the position of the satellite. So because of that, their transmissions are way more likely to happen from points that are on the east to points that are towards the west, right? And more on the equator, because the probability there is higher. They get a higher probability at the equator. That's the reason. That's the reason why this heat map has this particular shape. It's because that maximizes the probability of hitting the satellites in this fashion that I'm describing. So I think it's kind of, it suggests, right, that I'm on the right track on this. Let's call it idea. It's an idea at this point, right? It needs way further investigation and it needs experts to look at this. I am by no means qualified, as I said, to even talk about these things. We need an expert to look at this. But it also, I don't know, I think it reveals a lot of the mechanics of the network and the fact that it's asynchronous when you want to send data over long distances, okay? And it's real time or almost real time when you want to send data over short distances. That's another super interesting property. And understanding those properties for law enforcement, right? Understanding those properties is important because say that you want to eavesdrop on this network, right? To catch them in the act, so to speak. You need to understand this mechanic so you can maximize the positioning of your gear, of your agents, of your people, taking into account the dynamics of the network. Because the probability of transmission and catching a downlink is not uniform. It depends on the direction. And it depends on the relative positioning of the points, and it depends on the positions of bodies that are floating on the sky. So it's a very interesting challenge. And also, I don't know, it's just an idea. And then sometimes this happens to me, right? Where I have these ideas and I can't really, I feel like there's something there, but I can't really put my finger on it. And eventually, sometimes I get lucky and I can, but so I'm gonna say how it's more like a feeling, okay? It feels like this thing that I'm saying about the objects floating in the sky could be key to understand, not to understand, to guess where to eavesdrop. You can work the problem backwards. You can, and I have to think about this a little bit more. The idea in my head is not fully formed, but it feels, if you know what they're doing, right, and you know the mechanics of the thing, you could work backwards and eliminate 99% of the houses, for example, right now, right? If I look at Katy, this town, they have, say, I don't know, 55,000 properties, I think, for 54,000 to be exact, in Katy and the surrounding areas. If I was law enforcement and I had limited resources, and I said, I want to eavesdrop on these people to see what is going on. First of all, the first thing I would do is look at the GeoIndex by health.org, rank them, and go for the most important ones, the ones that have highest crypto payments, right? Because higher payments means higher importance and more legal risk. But then that would still, if you have 54,000 and you do that, say that you take the top 2%, okay? Yeah, I think this is the idea. Yeah, I see how it could be done now. Yeah, so if you have 54,000, right, and you take the top 2%, that would leave you with something like, so the 10% would be 5,000, the 1% would be 500, the 2% would be 1,000, right? Yeah, it would around 1,000. Still, it's a lot of people. But if you think about it, and you know the mechanics, and you have the kinetics, and you have the problem already solved for what they're doing, which I had a big subset of 1,000 potential high-ranking agents, allegedly, right? If you cannot just drop in on the 1,000 of them at the same time, what you can do is, okay, what are the houses that would be able to transmit right now, at this moment, or in the next 5 minutes? And you can tell that because you can work backwards. You need the other point. It's also easy because the antennas are fixed. So the only possible, it's a solvable problem. Because given that the sender, the position is fixed, latitude and longitude, the potential recipients in this, say that you put a radius of 500 miles, the potential recipients is a small subset of houses. Okay? Yes, because it has to be either on the same latitude or on the same longitude and has to be marked in the geo index. Those two conditions have to be met. Two of the three conditions have to be met. And then, yes, exactly. And then knowing which are the candidate houses and knowing the satellites that would meet this condition, that I think I could do this with the cluster I have. I think with that computing power, I can do this. Knowing, sorry, I'm just thinking about this on the fly. I should have thought about this before. Knowing where they could transmit and knowing the candidate points in space that could be that transmission possible, and knowing the kinetics and the geometry, you can figure out if the transmission is even feasible in the next 30 minutes. And that eliminates probably 99% of the houses and only leaves you with the ones that would be able to transmit. Yeah, I think that would be a good way to do it. Okay, so anyhow, I learned a bunch of things. So that's why I'm probably missing 80% of what I learned or what I infer from what I learned. So that's why I want to get that transcript from ChatGPT and publish it, because there's probably insights in there that could be useful to law enforcement, I'm guessing, right? If there's any merit to any of this, right? If there's no merit, please excuse me. I'm just trying to be proactive. I can be wrong, right? Everybody can be wrong. But if it holds any water, it could be an important discovery. And importantly, right, because of the implications and the legal questions it brings about frameworks and jurisdiction and, I don't know, ability to shoot down these satellites if they're really using them in this way. Those are very profound questions that touch on legal frameworks and policy and government and democracy. It needs a team of people to even think about that problem. So I'm not qualified to even touch it, to even think about it. But I want to show you the demo, okay? As always, I try to give things a kind of a positive angle, I guess. So I created this website, okay? And I'm gonna publish the address and everything. So the domain name is coca, as in cocaine, dash net, as in network, .com, as in commercial interest. So coca-net.com. And basically, it's a tool that does the computation for you. Okay. Yes. Okay. So I'm going to just tell you the features, right? So it has two radio buttons at the top, and this is to change the mode. Movable is the one I described where you have the freedom to move the antenna, and then fixed cardinal antennas are basically the ones that they have in the houses where the antenna is fixed. And here I basically picked an angle that I more or less measured or estimated from some photos I have. I think it's around this number in reality. And the assumption of this problem is that in each house, basically in this, how do you call it, simulated house, right? In this system, you basically assume that you have 4 antennas, one facing each direction, okay? And in reality, they don't do it exactly that way. Like they basically isolate the channels and route using software. But for simplicity, I assume this just so every point could communicate with any other point. Now, I have to say the fixed cardinal antennas feature right now is broken. Like it doesn't really work. I'll fix it, but I got it to work. It works beautifully. But we're gonna demo for now just the movable antenna, right? And there's another small box here. I put these 2 addresses as default. So the first one is my address here where I am. I'm saying this in case the FBI wants to talk to me or investigate the Salt Typhoon agents or that are in front of me, or the Citgo Russian FSB agent, Michael Pretty, that's next to me. Here's my address, right, in the first box. And then on the second box, I put Google New York as an example. But there's a small glitch. You really have to look for an address and click on it. Otherwise, it won't work. Okay. It will. Okay. Seems like it's working. Yes. There you go. See? So what this is telling us in this box over here, this is the result, right? So it's telling me that this satellite, Starlink 3672, will pass on this point 38.1903 minus 89.0101 at an altitude of 550.34 kilometers. And that is the exact point now. Like it basically has a countdown down that counts down until the exact second where you have to send your signal. And if you send your signal when the countdown down reaches now, according to the math, it is guaranteed that it's going to hit the target. In this case, the Google office in New York. So it's what this is doing, although the UI looks simple, the computational expense and the computational complexity here is immense. I had to really put a lot of engineering to make this happen this quickly. Okay. It's a whole distributed system on the back doing things in parallel so it could happen this quickly. You can pick any point. So for example, you can go from Bogota. Yeah, there's a problem with API. I don't know. I'll fix the API problem, but this was a good example that I showed you, right? Let me see. Okay, so this worked. And so, for example, for this example, the computation takes, yeah, it's working. The computation takes a few seconds. And for the other case, it's a way more expensive computation for the fixed cardinal antennas. That is a way more complex computation. But you see now it picked a different satellite. Now it picked the Starlink 1420. This shows that I know the satellite is really there, right, at this point. This shows, oh, I was showing you the wrong. So if you click on this link, yeah, you see the details about the satellite. I guess the important point beyond the functionality of the demo that I want to make is that it is possible to make these signals bounce in this way and to compute in a realistic, practical fashion a bounce point using a satellite as a bouncing point to achieve this goal, right? To make 2 points communicate over long distances without active collaboration of the satellite. And again, I want to highlight that point, active, right? Because maybe there was collaboration offline, right? In the makers of the satellite. Both, and I'm saying that both for Starlink and the other company that does a similar thing, or companies like the manufacturers of the materials that are used for the shell, for the exterior of the satellite. Because that's another way to do it, right? Controlling the companies that build the enclosure of the satellite. So you don't necessarily need to control the entire process or the entire design process of the satellite. You only need to control the design process of the shell of the satellite to make sure that the physical properties of that satellite optimize this goal. And I think there could be in that, if that holds any water, it could be something that shows design, intelligence, ingenuity, and a goal, a clear goal, right? And while doing all this. So anyhow, I want to apologize for the rocky demo. It's not scripted, and this is something that I literally started working on yesterday at 7 p.m., and I didn't sleep through the night working on this. It has a lot of bugs, and the UI is buggy, so excuse me for that. I'll make it better when I have a little bit more time. But today I need to prepare, so I couldn't keep working on it today because I need to prepare for tomorrow. Is what they call that, the mediation that Diosdado Cabello ordered that I attend to in regards to the divorce he filed against me and the restraining order he filed against me. So I have to prepare for that. So I couldn't keep working on this. That's why I'm giving this demo, although it's kind of half cooked at this point. But it shows the idea, and it shows that it's feasible, and the computation is feasible within a short period of time, which I think is what law enforcement really would look at, right? If they ever look at these videos. So I'm going to say goodbye for now and see you on the next one. Thank you so much.